Greetings, fellow nerds. Now I know I should really be doing experiments, but PopChess has sponsored this last Q&A video, and I'll be releasing one of my experiment videos next week Thursday on their website. As I mentioned before in earlier question-answer videos, I'm experimenting with using alternative video payment systems to Patreon and YouTube, so be sure to check in on Thursday for a link to that video. I'll also be releasing another different video here on YouTube so my viewers here don't miss out. After all, a good analytical experiment also runs control samples. I'll then comparatively analyze the viewer metrics to see how my experiment on alternative video platforms goes. Now let's get to business. As usual, big shoutouts to my new big sponsors, Simon Drew and Kevin S. Thank you very much for your contributions. Now, Simon Drew has pledged $100 and asked me to talk about research that can be done in an amateur lab. Well, Simon Drew, you didn't have to pledge $100. You could have just pledged $1, and I probably still would do your question since it's actually a very interesting one. But since you pledged $100 and requested a separate video, I'll go ahead and start work on that. Okay, on to questions for this video. Jason Black asks, how close have you ever come to disaster in the lab and what happened? Okay, my face was ripped off in a lab explosion. That was not a good day. I still have shards of glass embedded in various parts of my body. On the bright side, the person that was stitching my face back together in the emergency room was a really hot blonde med student. Next question, Ben Larson asks, I'm taking a World War I unit at my school and chlorine gas was used as a poison, especially during trench warfare. Do you know anything about the production of chlorine gas at the time? Thanks. I'm not certain exactly what process was used back in World War I, but historically chlorine has been produced by mixing hydrochloric acid and manganese dioxide. This would then produce chlorine and manganese chloride. Today, chlorine is mostly produced by electrolysis of sodium chloride. Okay, next question. Bang Engel asks, how would I set up an electrochemical cell to reduce nitroguanidine to aminoguanidine? Okay, I have no idea. Usually you would convert nitroguanidine to aminoguanidine using zinc metal. I think that would be a lot more straightforward than setting up an electrochemical cell. Keith asks, what are the difference between emulsifier, mutable solvent, and co-solvent? How is ethanol be classified when used to mix oil into water? Wikipedia might be a faster and more thorough resource, but if you really want to hear me and my sexy voice define physical terms, then okay. An emulsifier is a substance that helps stabilize an emulsion. An emulsion of two liquids can exist without an emulsifier, but usually they separate back into the two original liquids. An emulsifier prevents this from happening. As for a mutable solvent, I never actually heard or read that term anywhere. I tried looking it up, but I couldn't find any other resources that use that particular term. So I guess I don't know that one. Did you actually mean a mutual solvent? As for co-solvent, its dictionary definition is simply a solvent that's added to another solvent to enhance its solvating properties toward a particular solute. As for your ethanol question, you'd have to show me the exact oil, the temperatures, and the quantities you were using. It is very possible to have two liquids that don't mix at one temperature become soluble at another temperature. Kevin S. asks, in your last Q&A you stated that you got some chem waste and want to recover platinum and iridium. I have coal ash that is supposed to have trace elements and precious metals such as gold, silver, and platinum in the ash. I would be happy to send you some if you want it. Well, thanks for the offer. I probably won't be trying it since the amount of precious metals is very tiny. An amateur lab like mine doesn't nearly have the capability necessary to process the tons of ash I would need just to get a few grams of gold or platinum. But thank you very much for the offer though. Traden Kibbe asks, oftentimes for the home chemist, organic solvents are either cheap and ineffective or hard to purify, such as your toluene video. What merit does using Roncinol lighter fluid have as an organic solvent? From what I gather, it's mostly hexane, which is often also referred to as petroleum ether in the lab. Roncinol would make a very good non-poor organic solvent. I actually know of some chemists that use it for liquid extraction since it's cheaper than getting hexane. That being said, it is designed to be burned and not to be used for lab work, so very sensitive experiments might cause problems with whatever impurities it has. But as long as you need a non-poor solvent, and not a particular solvent, go for it. Pablo Soares asks, how can a chemist be absolutely certain about the contents inside a working vessel? Is there some kind of machine or process, such as spectroscopy, that can identify the exact substance or mixture of that the chemist has on his hands? Or does he have to rely on his stoichiometry skills alone? That is a great question, and even the best chemists of all time do not have a perfect method. There is no universal way that we know of to determine exactly what we have in a test tube. Sometimes it can be very easy, like a single element of gold that's very unique in its properties, or it can be very complicated, like the inner workings of a living organism for which we still don't know every detail. Particularly arduous is the work of biochemists that can spend literally decades trying to understand the particular composition, structure, and function of a complex protein. I wish there was a single machine that could give a perfect answer for any sample, but there isn't. As chemists, we have to use the appropriate methods for the work we're doing. If you're doing very simple work with very well understood reactions, sometimes your stoichiometry skills is all you need. But if you're doing research work in unknown areas that have never been tried before, then you need all kinds of equipment like mass spectrometers, HPLC systems, X-ray spectrometers, X-ray diffractometers, and so on. One of my personal favorite instruments is the nucleomagnetic resonance spectrometer. Now, philosophers would say that we can never know absolute truth and can only get asymptotically close to it. Personally, I hate their guts, and as long as my models perfectly describe my measurements, that's good enough for me. But we need a lot of work, measurements, and equipment even to get that far. Okay, that's all the time I have for this video. As usual, if you want to submit questions, send them to my Patreon feed. Next week, I'll be releasing 2 experiment videos, one here on YouTube and another on PopChest. Take care!